Hello guys, this is my project, single axis solar panel. Here the solar panel has a threshold voltage limit of 1.5 volts that I've set. If the voltage is less than 1.5 volts, it will start going into feedback mode, that is trying to find a better position. Now this is in feedback mode. Now we can see in the screen over here that the panel voltage is 2.1 volts. But now when I flash a high intensity light, the voltage pumps up to 4 volts or 3.9 volts and the panel stops moving. When I turn it off again, it goes back into feedback mode, trying to find the ideal position for itself. So I've used an Arduino Uno, a couple of jumper wires, a USB cable, an SMPS for now because I needed to power my servo. And then I've used a timing belt, some bushes, an aluminum rod, a clamp, breadboard, um, a solar panel of course, a couple of wooden battens, a base, a timing belt, and then I've used cushion for my servo because I needed it to be stable even when there are vibrations. And then I've cut a tube into half and I've put it, clamped it together. So this is basically my setup. Now going for my code, just closing the terminal. This is basically my code. Here the servo.h is a library from which I've imported the functions. Servo.write attach. My servo is a way of creating a servo object. I've initialized the I value with 1 and we don't need this dnt run. Okay, and now panel voltage, it's the voltage that we're getting from the panel. Here we have taken the, here there's a small breadboard that we've used over here. This is basically a voltage divider. We are scaling down the panel voltage because if the voltage is very high, it may damage the port pins of the Arduino. So over here you can see we have created the we have used the serial begin. So this initializes the serial communication with the general baud rate 9600, and then we have attached the servo to the pin 9 of the Arduino. You can see over here servo is attached to the pin 9 of the Arduino, and then we've gone to read panel voltage. So here multip is a multiplier. This is like any other A to D conversion. And then once we've created this voltage that we've converted the voltage that we need, we're going into the loop. For every iteration of the loop, we're checking if the voltage is less than 1.5 volts. If it is, we're writing I and incrementing it to for it to go to a better position. Else we're continuing it. So with this continue statement, this goes to the end of the loop. The control goes to the end of the loop and it again goes to the starting of the loop. So basically what happens is, if the voltage is greater than 1.5 volts, it will continuously be doing nothing. It will be going through the iterations, but it will be doing nothing. So the servo will not write any angle to itself, so it will not move, it will stay constant. So this is basically my code. That's it. Sorry. See, now let's see the panel voltages now. Now the panel voltage is 1.55 volts. Now if I push it back, it is 0.33 volts. Now switching the light to a more intense way. It's 2.6 volts, so it's staying constant. Now it's decreasing. Just put it like this. 3 volts. Okay, let's go to the most highest intensity. It will be directly to the 4 volts. 4 volts over here, and the panel stops moving. And we turn the light off, going back into feedback mode, and we turn the light on. 4 volts, it's staying constant. So thank you guys. Have a nice day. Please like, share, and subscribe.